Hi guys, in this video I will show how to solve the system of linear equations, and as you can see here, let's try to solve these numbers let's try to solve for x, y, and z. And the first step we have to do is to augment the equation here, the linear equation, by doing the augmentation for it. So in the first row, let's say this x, this is y, and this is z. And it's equal to whatever number we have, which is n. So for the first row we do have 1 and the y is -2 and z is 1, and let's say for equal in the matrix, let's make it a dotted line and it's -6. Okay, let's try to solve for the second row, which is 2, -3. Because we don't have z here, so we will just set it to 0, and it's equal to -7. In the third row we do have -1 plus 3y, so just uh, play like the 3n, and -3z, and it's equal to 11. Okay, so now what we have to do is we already have 1 here, so what we have to do is to change the 2 and -1 into 0. So to do this, we have to multiply the first row by -2, so -2 times r1 plus r2, so it will give us r2. And let's just to do 2 steps and 1 action. So, and to make the -1 into 0, just make r1 plus r2. r1 plus r2, it will give you the r3. Okay, so let's say this is the second step. So because we are not doing anything with the first row, just add it as it is, which is 1, -2, 1, -6. Now we do have to do the multiplication for the second row. So -2 times r1, which is -2 times 1, plus 2, and it will be 0. And -2 times -2, which is 4, plus -3, it will be 1. -2 times 1 plus 0, it will be -2. And -2 times -6, it will be 12, minus 7, which is 5. Now let's try to find the third row by adding r1 to r3, and it will give us r3. So 1 plus -1, it will be 0. -2 plus 3, it will be 1. And 1 plus -3, it will be -2. And -6 plus 11, it will be 5 as well. Now try to make this number and this equal to 0. Why? Because it's above and below 1. So let's say 2 times r2 plus r1, it will give us r1, and -1 times r2 plus -1 times r2 plus r3, it will give us r3. Okay, So now let's do the third step. So as I said here, we are do the multiplication for row 1 and row 3, and we are not dealing with R2, so just plug it as it is, which is 0, 1, -2, and 5. So 2 times 1, let's say 2 times 0, it is 0, plus 1, and it will give us 1. 2 times 1, it is 2, plus -2, which is 0. 2 times -2, which is -4, plus 1, it will be -3. 2 times 5 is 10. 10 plus -6 is 4. Okay, so now we are done with R1. Let's try to solve for R3. So -1 times 0 plus 0, it is 0. -1 times 1 plus 1, it will be -1 plus 1, which is 0. -1 times -2, it's 2, plus -2, which is 0 again. And -1 times 5 plus 5, and it will be 0. Now let's try to solve for -2 and 3, and or no, I guess we are done with the problem because we do have 1 0 0 0 1 0, and whatever you do here you can get a 1 for it. Or let's say -2 times R2. Yeah, so we can solve this problem by let's say that the x1 is equal to x1 minus 3x minus 3z is equal to 4, and x2 minus y minus 2z is equal to 5. And let's say that this is x, this is y, and z is any real number. Why? Because z is the free variable in the matrix. So let's say that z is equal to s or t. Let's say it's equal to t. So x1, it will be x1 minus 3 times t equal to 4, which is x1 equal to 4 plus 3t. And for y, let's say y minus 2 times t equal to 5, which is y equal to 5 plus 2t. And z is t such that, let's say, to interpret this equation, let's say that x and y and z such that x is equal to 3t plus 4 and y is equal to 5 plus 2t and t, such that t is any real number. And to say, because it's all zeros here, So it tells us that the matrix is dependent, which is too many solutions. And we are done with the problem. Good luck in your exams.